Letters are one of the most important links between people who live far away from each other. Hence, posting a letter is a familiar, everyday sight, something we all do, some of us more than others. There's always the thank you letter to send to Auntie Flo, the all-important pools coupon, the income tax return we leave as long as possible, sometimes even a request or two to Father Christmas. We just write the letter, pop it into an envelope, find a stamp, post it, and breathe a sigh of relief. It's all quite simple. But it's what happens next that is really important. Because all our cards and pools coupons, birthday greetings and tax demands, and the little present for Jane's 21st, add up to a staggering total of 35 million pieces of mail a day. Yes, the figure really is 35 million. If we put all these letters together, they would weigh as much as a dozen big airliners. And placed end to end, they stretch, well, a long, long way. Just how do the GPO cope with this staggering daily problem? Well, up till now with men, and this has worked very well indeed. But the GPO like to be one jump ahead. For years, their research and development experts have been working towards the ultimate logical answer, mechanization. But mail resists regimentation. It comes in as many shapes and sizes as the people who post it. Machines can be made to churn out Easter eggs or plastic components because they are uniform. But how can machinery be made to cope with the volume and variety of our mail? Let's see how it's done. Let's look at some of these 35 million letters and packages a day and see how they are handled in a fully mechanized sorting office at Norwich. Once the mail has been collected, the first problem the GPO has to face is how to divide it all up, how to separate the packages from the letters. And they do this with a machine called a segregator. It's ingenious and simple. When you come to think about it, quite a lot of ingenious things are simple. All the mail is tipped in here. Everything, all shapes and sizes. And so it begins its automatic journey. On its way up this conveyor belt, it passes over a beater, a sort of vibrator under the conveyor belt that helps to spread and even out the flow of mail. Then it all slides into this large revolving drum. This drum turns about 8 times a minute, and along it are a series of narrow slits. As the mail revolves in the drum, letters slip down through these slits, while the thicker packages slide gently down to the end. So, in this one simple operation, we have segregated the letters from the packages. Underneath the big drum are more conveyor belts, and the letters slide down through the slits in the drum onto these belts. But because envelopes come in so many different sizes, the next problem is to divide the larger envelopes from the smaller ones. And with 35 million a day to deal with, it would take an awfully long time to do this by hand. So, here's the answer. A series of rubber rollers which snatch out all the larger envelopes from the flow. It looks simple, but it's really a result of a lot of hard work and thought. See? The larger envelopes are snatched out and separated, and the smaller ones underneath left to continue their journey. So now the segregator has divided up the mail and stacked all the larger and smaller envelopes. Now another machine must make sure that all the letters are the right way up, all with the addresses facing us and the stamps in the top right-hand corner. This machine is called ALF, and it's really a series of machines in one. The initials ALF stand for Automatic Letter Facer, and that's just what it is. Letters go in upside down and back to front, and ALF turns them, 20,000 of them every hour, so that every stamp is in the right position to be cancelled. It does this by reading the stamp itself with split-second accuracy. Finally, it cancels the stamps and puts the letters in a pile ready for the next operation. But the time must come, even with mechanization, when the address on the envelope has to be read. And one of the innovations of postal mechanization is postal codes, like this one, already in use in parts of the country. These are essential to enable the fullest use to be made of all this new equipment. At coding desks, the operators read the addresses and the codes as they appear in a small window. Each time they tap the keys, this machine automatically imprints a series of harmless phosphor dots on the envelope. This process is repeated as each letter passes in front of the operators, and as you can see, they can comfortably keep up a good speed. The phosphor dots imprinted on the envelope are really an address that can be read electronically. And these phosphor dots are perhaps the stars of our film. All the letters, now with their individual phosphor dots, are fed into a high-speed sorting machine. In large towns, it's often useful to be able to sort letters very rapidly to a limited number of destinations, and to be able to take out large numbers of letters which may be addressed to places nearby. This machine is called high speed because it can deal with 20,000 of our letters every hour. It scans the phosphor dots on each envelope at these speeds and divides and stacks them all in their appropriate stacking unit. All these stacks represent different areas to which the letters may be addressed, so that at the end of this high-speed operation, they are ready to undergo further sorting in yet another automatic machine which will break down these bundles of mail even more into 144 compartments, all of which have their place names marked clearly on them. Again, this automatic sorting machine makes use of the phosphor dots on the envelopes. And here perhaps we should take a look at just a little of the wizardry that makes these complex machines tick. They're called translators. Each is a brain, really. But even these days, when computers are becoming commonplace, these really are very complicated pieces of equipment. Unlike our fallible human brains, once these have been taught something, they never forget. This equipment does two things. It instructs the coding machine on the combination of phosphorescent dots to mark on the envelope, according to the keys the operator has depressed. Then it tells the automatic sorting machine which box to put the letter in. As the automatic sorting machine scans the phosphor dots, signals flash to the translator at fantastic speeds through circuits and relays. These signals ask the brain what to do. And in a flash, the correct answer speeds back along all the wires to the appropriate machine where these same impulses open a trap door in exactly the right compartment at exactly the right time for the right letter. There they go, our letter to Croydon among them, in a nice, neat, automatically sorted stack. One translator can control several sorting machines at once, and, if necessary, convert to any one of many different sorting plans at just the flick of a switch. This is what mechanization really means. And if no machine has yet been invented which can walk up and down the garden path and push letters through our letterboxes, and if the familiar postman doesn't appear to have changed much as he prepares his mail for delivery, the organization behind him is changing. Mechanization, a complex of men and machines, is transforming Britain's postal service into a modern, streamlined network to speed the mail ahead of the times.